Hi, everybody. Thank you for joining me for another. I should be like Sheldon, and it's instead of fun with flags, it's fun with radicals, or we need some kind of fun thing to go with this. So we are going to look at what happens when we are adding, subtracting, simplifying radicals, also multiplying them. I'm going to be honest, I don't have a calculator in front of me, so we're going to do this the hard way. But you have a calculator if that helps you um, find some relationships. But for 405, really, right now, the best thing that I can see is to divide by 4. I want to, or not 4, divide by 5. I know that 5 is going to go in there. 5 goes into 40 8 times, and then 5 goes into 5 one time. Bryce, will you shut my door? It's going to be a little loud today, probably different than normal because I am doing this after school, so sorry about that, guys. Now, 81 is going to split into 9 and 9, and then 9 and 9 split into 3, 3, 3, and 3. Now, this is awesome because I'm trying to take the fourth root. So if I want to take the fourth root, bless you, I have 4 3's. So that means that 3 can come out. The negative stays on the outside like a -1. And so my answer is going to be a -3. I have 1 5 left over that doesn't have the other 3 that it needs. So it has to stay underneath the radical. So it would be -3 and then the fourth root of 5. If you can't simplify radicals, then that's going to be a problem when you're trying to multiply and divide and add them, because we're going to have to do that all the time. Now 125, we should remember back from our sum of cubes and difference of cubes, is actually 5 cubed. So if you weren't sure what to do with it, you can definitely divide by 25 and get 5, or divide by 5 and get 25. And then you can say that 25 times is 5 times 5. And so we have 1, 2, 3 5's, which is what we're looking for because we're taking a cubed root. So that 5 can come to the outside. I know that I have a 5. If I have 6 t's and I'm trying to take the cubed root, even if I wrote them all out, 1, 2, 3, 4, 5, 6, that means I have 1 group of 3 and 2 groups of 3. So t squared can actually come out from underneath your radical. If I have w squared and I want to take the cubed root of it, it's impossible. I have to have 3 of something before I can take the cubed root of it. I only have 2 w's. And so my simplified radical is going to be 5t squared and then the cubed root of w squared. If I'm going to multiply these two, I don't have to FOIL anything. I don't have any plus or minus, we're not adding any terms, but we have to multiply the two numbers in front and then multiply what's underneath the radicals. So if we have 3 times 4, that's going to give me -12. And then it's up to you. At this point, you might want to leave it as 15 times 45. The reason you may want to do that is because obviously if it's a square root, we're going to be able to do something with those particular numbers. We're going to be able to simplify that. If I have 15, that breaks down into 3 and 5. If I have 45, that breaks down into 5 and 9. And then the 9 can break down into 3 and 3. So I actually have 3 times 5 times 3 times 3. So all of these are my factors. And if I want to go in pairs, I have a pair of 5's and I have a pair of 3's. So So we can factor those out to the front. I've already got the negative 12 out there. Then I can factor that 5 out to the front. Then I can factor the 3 out to the front. And then I've got the square root of 3 still left. Now trying to do mental math, that's negative 60 times 3, which would give me negative 180 square root of 3. If we want to add or subtract, when we look at our radicals in this particular situation, we can't do anything. We can't do anything because they're not the same. However, we can obviously break down a number like 810. It's very easy to know that actually we can do 9, can't we? Because 9 goes into 81 9 times, and then you have a 0. 9 times 90 is going to give me 81, or 810. And then I get another 9 times 10. 9 times 9 times 10 is going to give me the 810. But if you want to break it down some more, you can. If you've got 2 9s, you're good. You can already go ahead and factor out the 9. And then you're left with the square root of 10. 240, as I said in class all day, I know it's divisible by 4 because 4 goes into 24 6 times, and then I have a 0 because it's not just 24, it's 240. If I have 60, it is divisible by 4 as well, and that would give us 15. And then 15 is just divisible by 3 and 5. So really the only thing that helps me out here are my 2 4s. And so I can bring that 4 out to the front, but I'm left with a 3 and a 5 under the radical, so I'm going to leave that as the square root of 15. My last radical is 250. We should all see that it's divisible by 25. 25 is wonderful because it is 5 times 5. So there's my pair. I can subtract that 5, and what's left under the radical is that 10. I can't do anything with the 10. Now once I get to this point, I have 9 square root of 10 plus 4 square root of 15 minus 5 square root of 10. This is the whole ABC thing. These two have the same last name. They're both square roots of 10. If you have 9x minus 5x, you just get 4x. So 9 square root of 10 minus 5 square root of 10 is going to give me 4 square root of 10 and then plus 4 square root of 15. That's my answer. Here we're going to be multiplying. Our first problem, I did this on purpose because a lot of times we forget that if we see a binomial squared, you have to rewrite this. This means 3 minus the square root of 7 times 3 minus the square root of 7. It does not just mean square the 3 and square the square root of 7. We have to use FOIL. Our first gives us 3 times 3, which is 9. Bryce, will you let her in, please? And then we have 3 times negative square root of 7, which is negative 3 square root of 7. Then we have negative square root of 7 times 3, which gives us another negative 3 square root of 7. And then we have this negative square root of 7 times negative square root of 7, which is negative times a negative, or a positive. So we get a positive, and the square root of 7 times the square root of 7 is the square root of 49, or just 7. Hopefully we're starting to see that if we have the square root of the same thing, that's where we go. Now if we have 9 and 7, that gives us 16, and negative 3 square root of 7 and a negative 3 square root of 7 is negative 6 square root of 7. Now I'm going to do the next one. My first two terms are 1 times 5, which is 5. My outer are 1 times negative square root of 7, which is negative square root of 7. My inner are 5 times square root of 6, or positive 5 square root of 6. And my last are negative square root of 6, square root of 6 times negative square root of 7. Now, positive times a negative gives me a negative, and the square root of 6 times the square root of 7 is the square root of 42. Square root of 42. If I think about 42, the only thing it really factors into is 6 times 7. And 6 and 7, 6 doesn't have any perfect squares, 7 doesn't have any perfect squares. So the square root of 42 really isn't going to go anywhere. We just leave it as a square root of 42. So honestly, I'm done. I've got a whole number, I've got a square root of 7, a square root of 6, and a square root of 42. I can't combine any of those. So I'm good. That's my answer. If I want to rationalize my denominator, I can't really divide anything here. What they're asking us to do is simplify, is to rationalize the denominator, meaning get that radical out of the denominator. So if I have 5 minus the square root of 24, I'm going to multiply by 5 plus the square root of 24. As I said before, this is the conjugate. Bryce is helping clean up my room as you're hearing things fly across the room. So I have 5 minus the square root of 4 times 5 plus the square root of 4. The reason I want to do that is because it is going to get rid of the radical in my denominator. It's going to give me 5 times 5, which is 25, a minus 5 square root of 24, and then a plus 5 square root of 24. Some people don't even write those out. Some people just know if we're using the conjugate that your inner and your outer are going to cancel because one's going to be negative and one's going to be opposite. And then we have negative square root of 24 times square root of 24, which is just going to be 24. Now this one's beautiful because 25 minus 24 is just 1, and so we don't really have to worry about the denominator at that point. We just have to clean up this numerator up here. So we've got 3 times 5, which is going to give me 15. We've got 3 times the square root of 24, which is just going to be 3 square root of 24. I'm stuck. Well, I'm surprised. Where did I get 3 times the square root of 24 down there? So we're good. We'll clean that up in a minute. I'm surprised I used the square root of 24 because you can clean up the square root of 24. But moving on, it took my brain that long to figure it out. So we have 3 times the square root of 24. My inner is going to be 5 times the square root of 6. And my last is going to be, and this is where I'm going to help myself out. I'm going to leave this 6 times 24 underneath that radical because I'm going to have to break it down some anyway. Cleaning this up, 15 stays the same. 24 has the perfect square 4, so I can bring that 2 out. I can separate this into 4 times 6, which will allow me to take the square root of 4, which is 2. And then 3 times 2 is going to give me plus 6 square root of 6. 5 square root of 6 I can't do anything with. it has to stay the same because you can't do anything with the square root of 6.